Next sessions will be starting at exactly 8. I'm not a 1 minute past 8 person. If I see it, I want us to do it because I believe other people also have other schedules aside of this. You also have family to deal with and all that. So let's respect our time and yeah, so we could get things done ASAP and proceed to other things. So, like we had our introductory session last week, today basically we'll be having a master session how the internet works. These sessions, maybe as time goes on, I won't be the one handling them. I may be bringing in some senior engineers to take some of those master sessions, so that it won't be like a monopoly sort of, right? So maybe while we interact with other people, we also get to like see what they think and see how they solve problems and see how they see problems basically. But for these first two master sessions, I will be handling them. So at the end of the session, I'll share the breakdown on how our learning is going to be like. Um, yeah, I'll explain all that. So today, basically, this topic is a very interesting one, how the internet works. We use internet every day, every damn day. Everybody on this call is using internet at the moment. So I'm now curious to ask, what do you think the internet is? Yeah, feel free to use a chat section. I'm using my second screen now. Be able to see what you drop in the comments. So yeah, let me understand, what do you think the internet is? Yeah, you can feel free to maybe unmute and take few seconds and tell us what you think. Basically, what do you think?
Good evening, sir.
Even in destiny. Good.
Okay, sir. I think the internet is a space that connects people together or connects information together.
Makes sense. Okay. Space is peace that connects people.
Good evening.
Yeah, good evening. Shoot. Go on. We can hear you.
Can you hear me?
Yes,
Okay.
please. Yeah.
So I think I believe the internet is a massive network connecting devices all over the world, from personal end devices to servers that store files and to network devices that enable this connection between the various devices.
Makes sense. All right. That's a good one.
Right. Okay.
Remedy.
I see the internet as a global environment where that offers a platform for the world to interact.
Makes sense.
Okay.
Um, can we have maybe one or two more questions and then we proceed? Okay, no one is talking, so I'll assume. Yeah, those are actually good feedbacks. Um, but you'd be surprised at what I will tell you. What if I tell you the internet is just a cable? It doesn't make sense, right? Okay, yeah. Growing up, we thought internet was one big cloud out there, something running in the sky, one cloud where people could just put connectings and all that. Yeah. So we've looked at it like one magical, fuzzy cloud floating in space, a mysterious, invisible force that just works. Like you are not seeing it, but it's just working. That was like the idea people actually created, right? They just created that idea. They were just more concerned about their job security than education. But trust me, that's not what the internet is. It's just a wire. Quote me anywhere. You can also do your own research, right? So
Good
basically,
evening, sir.
yeah, good
Yeah,
evening.
I think internet enables two or more computers to connect together.
Yeah, we can take that too, right? So basically, it's like I was trying to explain, it's just a wire. Maybe actually a wire that is buried in the ground. I mean, okay, I'll be tempted to ask that, how do
Service here
Nigeria
is bad.
get my thing is your network? Just kindly mute kindly. Thank you. So basically, I'll also be tempted to ask, how do Nigeria as a country has internet? Like, do you know how we have internet? Do you know how Nigeria as a country has internet? So there are actually some cables that run, okay, submarine fiber. Exactly, there are submarine fiber cables. We have MTN has a cable that runs from the Atlantic Ocean. Almost all those cables are in Lagos. We have Mean One. I think there's Afri Two. There's Glow One. That's our Nigerian cable, and yeah, so they are just cables. So you see, when it's like you have like a long cable, there's a server connected to that cable, or you connect a device. Oh, let me just bring us back to when we were kids. You tie a long rope, tie some small thing like those dispensable cup. You stand and cover your mouth. The other person is standing at the extreme end, and then you speak, and the person is able to hear what you're saying. Like there's a transportation that runs through those wires down to that end. So that's like a communication. So just see this guy that is talking and the one that is listening as your servers. So internet, like I was trying to explain, basically, it's a wire, right? It could be a fiber optics cable, a copper wire, a satellite signal, but always it is a physical connection at its core. The core of it is a wire that is connected to multiple computers called servers, right? So the internet is just so I'm trying to accept some people in the call. So it's just a wire that dedicated computers called servers are connected directly to them, right? So how do we then accept or have access to internet? That's where we now have our ISPs, that's the internet service providers, right? Like the MTN, like the Main One, Afri, like the Glow, that already now have a dedicated, they run those wires to their own infrastructures, and then those infrastructures now distribute signals that we're able to use our small mobile devices to tap into it. That's an internet. It's a wire. It can be another sea cables, right? Look at fiber is just like the last meter of those things. It's just like, for example, let me give you have like water board. They run water from location A to another town or another location B. Then inside of your house, you now have taps that you just go and turn on this tap. So those taps now that allow you to fetch water, you're not using that major big pipes that run from one community to another to get your access to water. You're now using a tap that was connected through. So look at your fiber network, sorry, your Wi-Fi network as now a tap connected to a major source of water. A tap connected to a major source of water. So that major source of water, that's what we refer to as the internet. Then when you're now looking at, so your ISP now plug into, it's like maybe I don't want to use Abuja for example because there are people not based in Abuja. So that's why I'm using location E. So let's say location A, location B, right? There's a big pipe running water that has water channeling taken from A to B. That's your internet. Then when on getting to B, location B, there's now a group of people that now build up another system where they can tap into that big pipe, connect into that big pipe so that they can channel this water small to people, and then people can consume it in their household. Those group of people now are the ones we are referring to as the ISP, internet service providers. So they just tap into the main and then distribute those network, and then we'll start using it. And so, oh, I don't have internet. You have internet, you don't need to have it. It's maybe, oh, I don't have internet to connect to this. Actually, it's your ISP that is not giving you access to connect to these things and all that. So basically, in the nutshell, that's basically what internet is all about. You can also go and do your own research to understand some of these things in details, right? So now there is like a server and client, so communication, right? So there are two things here now. So when referring to as the client, that's like you as a person. You can also look at it in the side of what we will be building. We are learning front end engineering throughout this program. So we are building the client side of things. When they refer to client, they're referring to like user facing part of things, the things that you actually interact with. So if um if a user is interacting with your web application, for example, you log into your, let's say, Instagram now, you are seeing feeds, you can type. Those are like the user facing side. Those are like the client side, right? So what we are building now is the client side. So when they are referring to like front end engineering, that's all the technologies that involves building the client side of an application. That's what this whole program is all about. So that was why I felt like, okay, let's get to the grassroots, understand what you want, learning how to build first. So then there's like the server side. So yeah, I was trying to paint a scenario of maybe a shop. No, we'll come to that, right? So that's like, but I get to understand what I mean by like the client side. What you can see. So there are a lot of gadgets, maybe your laptops, your phones, tablets, smart TVs, all these things that you can interact with. You feel them, you can touch them, you can message via them. Those are the client side, that are the user facing side of things. So when somebody is referring to like, okay, how is your, even from the code base, sometimes if you're looking at a developer's code base, you can see, you could write something like, put a folder and say, okay, this is the client, this is the server. The client here is now referring to, this is the front end of my application, this is the back end of my application. So what we are learning now is how to build the client side of things, right? So like I was trying to explain, right, you currently do not directly connect to internet, right? What you connected to is your ISP. They just give you access to route through the internet. And then there's the other side, which is like the servers. So like I was trying to explain earlier, if you look at the internet landscape, there are dedicated machines called servers hosted in different locations, different data centers. The work of that machine is just two things. It stores information, and then it allows you access to the information. And maybe if we want to go one step further, we can say it allows you to manipulate that information. A situation where somebody is creating an account is like you trying to store information to the server, right? So maybe sometimes if you see you're building an application and they say, oh, we want to deploy our server. That's, we want to now deploy our own special computer somewhere in the cloud where we can store information there and be able to retrieve it. And these servers are actually stored in those virtual big computers that are connected directly to the internet. So when you're looking at a server, that's just like, it's a big bulk of computers standing somewhere in a big, large room with ACs running up and down, running to keep it active and cool, right? And then when you pick your phone, you type www.google.com, it's like you then, that's, I think I'm running faster, right? I'm going down, I won't go down this slide. This topic is actually an interesting one. Like, I like to talk about it a lot. So when you type in maybe www.google.com, it then routes you to a particular server that stores the information about that Google that you want to access. And then that server now start giving you back responses. So that dedicated machine, his job is store information, allow people to access the information and manipulate it. It's just like an open library where you can always go there anytime to pick a book, read, and maybe return it, or try to read and return it, sort of, or get any information. So basically that's just what internet is, and that's how we actually try to communicate with internet, right? So now if you look at your ISP, I remember I said this means internet service providers, and I think I mentioned a couple of them. That's MTN, we already know, Glo, all of those guys are our ISPs, right? They give us access to internet itself, right? So like we already said in the previous slide, you do not connect directly to the internet. Your ISP does it for you, right? So your device, which is your laptop, your phone, and then you have like a Wi-Fi. So it's connected to maybe like a Wi-Fi. For example, I'm using one here. I don't want to raise it so that it will go off and affect my call. There's one standing beside me here. SpectraNet, actually, right? So your device connected to your Wi-Fi net, your Wi-Fi, that's the device right here. I think I even have one here, another one. And then these devices are usually owned by ISP providers. Could be MTN, could be SpectraNet, could be Glo, could be whatever you're using, right? So the ISP are the ones that then connects directly to that bulk of running water, right? And then, so through your computer, you are able to access internet via an ISP, which is your normal service provider. So once you have access to this internet, you are able to search for files, watch videos, do this communication we are having right now. And that's just how the client server internet communication just is being routed, basically, right? So Wi-Fi versus, so maybe if we want to look at the difference between Wi-Fi versus the wired, I think I've explained this. So Wi-Fi is just a wireless version of the same cable connection. The internet still travel on physical wires. The Wi-Fi just remove the last few meters of cable between you and your router. Like I was trying to explain the issue of maybe having your water system, your shower running in your bedroom and all that. Your shower is not connected directly to maybe, yeah, even if you're in your normal house setting, it's not connected directly to your water pumping machine, right? It's connected to the tank that supplies water to the house, but there's something that runs that water up. Your pumping machine is not connected directly to the pumping machine. Yeah, I'm just using that for instance, right? So what your ISP does basically is the one that owns and maintains those physical cables, those equipment that connect your neighborhood and to the global internet backbone. That's how basically that's how maybe we could define what an internet is. Any reactions before we proceed? Any quick reactions?
Yeah. Wow. Interesting. Very, very
Stress.
interesting. Yeah. Yeah.
So
You
now
know.
let's get to the fun part of it. All right.
Okay.
Every device has an address. Every device has an address. And this is what we refer to as your IP address. Those things are combination of numbers. For
Internet protocol.
example, yeah, they are just combination of different numbers. So, for example, now, it's just like your phone. It's just like your look at it. It's just like your phone book. There is a directory called, we have DNS. Most time you see DNS, DNS.
Domain name system.
Domain name system. Let me put it in the chat. DNS, domain name system. So this DNS is more like, look at it like a book, like your contact. For example, you want to call me, for example, right? You have my contact. My name is Samuel. You saved my number as Samuel. You want to call me. You don't know you don't know my phone number of heart. You don't need to punch my phone number to call me. Already you have saved my number with a name. You can save it as Samuel, you could save it as ICTs, or you could save it as anything, but it's a name that is mapped to a phone number. So that when you look for that name, or when you punch die on that particular name, it is the number that is being called. That's just how DNS, and IPs work. Every website you visit out there, every resource you try to access on the internet, could it be if it's an image, a video, or whatever is that thing, it has like an IP address, right? It's strange, it has a number. For example, Google also has I think Google is one for, let me check quick. Google also have their own like basically, right? I don't need to start doing all those checks. You could do your own research as well. Every website, if you are typing www.facebook.com, for example, is just the same thing as you dying somewhere and then the number is being called. So when you type www.facebook.com and hit enter, it's like what happens on your devices. Your device is routed to a DNS, a domain name system. The domain name system now check its address, its directory. Okay, this name that is coming in now is mapped to this particular IP address. This IP address is located on this server in this particular place, and then it then redirects. So that redirection is happen. It usually is being managed by routers. That's like another conversation. So, but what I'm basically saying, there's like a traffic guy that now say, oh, this name is mapped to this particular IP address that is in this location, to now direct you to that resource. And then before you know it, now start seeing Facebook on your phone, start interacting with it. So those are like some of the funny behind the scenes. This brings us, why do I want you to know this? For example, you do a deployment, you build your own front end, your website, you have deployed it somewhere. That place will now give you DNS records with IP addresses that you have to pick them and then connect to your custom domains. Most times, 85 or 99.9 of developers, you see them plugging in DNS records, but they don't know what actually these things are, right? So that's why I felt like, okay, let's come back and understand some of those basics, right? So the concept behind this whole training was get the fundamentals as quick as you can before you can start exploring funny things, right? So basically, that's what IP address is basically, and DNS. That's like the relationship. So now let me put in IP address together, DNS system, servers, internet, ISP together. Now, if you bring all of them together, you visit a site. What allows you to type facebook.com is your ISP provider that connects you to a pool of resources. So you then tell your ISP provider that I want to go to facebook.com. It redirects, sends this connection to a server that has like that, a server. I'm referring to a DNS system now. It then routes it to another dedicated server or dedicated library that has that information, and that information is then routed back to you. All these things happen within milliseconds. Happens very fast that we don't even know what actually went or what actually happened, right? So that's like the connection between all these other things, right? So like I was trying to say, so you just kindly think of an IP address like your home address. For the internet to deliver information to your computer, it needs to know exactly where you live. I think Kende, you have to leave the call and join again. Or is anyone else having the issue of not seeing my screen?
It's a call that came on my phone.
Now,
It's okay.
join, I've got out and join again. Still the same thing.
Just a quick check, guys. Can you see my screen and can you hear me? I think it's the network from your end. All right. So basically, like I was trying to explain, so you could just still do it, your own research, read all these things together. I want to make this session a very brief one so that at least we understand the key fundamentals. I already onboarded you guys to the LMS, so you have, I think the lessons there are much compared to what we have here. This is just a master session, right? Yeah, so DNS, I think I've also explained this. So this is like the internet phone book, like we said. So nobody memorizes an IP address. There are long strings of IP addresses. So you just have to memorize them.
Are you there? Sasit, your network went down or something like that. You are not getting anything from your end.
Hello guys, sorry, I'm back.
Okay.
I don't know what happened. My light just tripped off, and
Okay.
my ISP device went off.
Oh,
So I lost connection to the internet. So I believe everything I'm saying now makes sense, right? Yeah, cool. Okay, let me share my screen again. Good. Okay, yeah, so like I was trying to explain about the DNS record, it's just an internet book out there, just like your normal phone book, the way you save your contacts. It saves anytime somebody says buying a domain, it's as good as the person is registering that domain in an address book. And then that address book now generates an IP address. And then he now connects it so that anytime somebody visits the website, he now also have his own records in the DNS system that get redirected, right? So nobody actually memorizes those IP addresses, those numbers, but DNS converts the name to numbers automatically, right? So without DNS, to visit Google, this is what you type. This is Google's DNS IP address, right? So without DNS, if you want to visit www.google.com, you'll be punching 1.42.250.185.78 on your device. So, but now that we have DNS system, you could easily type google.com and then DNS try to magically convert these words into this IP address, and then you get redirected to that place. So this is just how the loop works. You type Google and then hit your enter. The browser check if it is cached. That's if you have already visited that site before and then it is saved. And then it asks your ISP DNS resolver for help. The resolver asks the root, that's the .com, and then it gets back to google.com, that's the IP address now, and your browser connects to IP address, and that's done. You now have access to Google, and you now start shuffling their resources, seeing everything that is happening in the Google ecosystem. And that's just what happens whenever you try to visit a website or consume a resource on the internet. There's a cool part. There's a cool part to it. There's a sweet part to it. Packets. Let's say, for example, now you want to uh, okay, let me give you this typical real life scenario. Whenever you buy, if you're buying these small cars, in Lagos they call them kulukpe. Here in Abuja we have is those small buses. I don't think there's any name for it here in Abuja, but in Lagos they call them kulukpe. So it's those small mini high jet buses, right? So whenever you're buying those things, that thing come in a box, right? It's dismantled. They just package it in a box, in a container, and then they'll just send it to you. So when it gets to your location, or maybe gets to the assembling plant, they then now assemble that thing together into a small mini bus, a car. Most times, some estates in Abuja use them for transportation, right? In Abuja, in Lagos, is popularly used on the roadside, like used as along the way we call it here in Abuja, right? So that's like let's bring that concept back to what packets are. Let's say you want to let's say I'm sending an image from my WhatsApp to your own WhatsApp number, for example. I'm sending you an image. This is how that image travels. It doesn't travel as one full image to that person's device. No. The internet breaks that image into small pieces called packets. Those packets travel individually. They go in bits. Some may arrive before others. That's why sometimes, this is how, if you want to take note of it, you know, when you load a particular website that has images, you see there's like, it comes as a break before, you know, the thing now forms into one whole image. You now see, oh, this is an image. Or let me give you another example. You're watching a video on YouTube and your network is bad. You see like there's one cracky rag, or you're even watching a movie on Netflix with your internet. You see that, oh, you see, my network is not good. The movie is breaking, it's cracking, and all that. Or you're even having a call, and then you now start, oh. Like, all communications via the internet travel in packets. Or maybe you're even having a Google Meet like this, and then sometimes you see the person will talk, you see the mouth move after some time before the words come. So basically, all communication on the internet happens in packets. When I say, now that I'm talking to you, if I say a word, it's broken down into pieces called packets, and they travel at different speeds depending on now how good your ISP infrastructure, so network is. That's how you then get this connection. Now they don't travel at a faster speed and then arrive to that person like in real time. See, you now say, oh, we are having a conversation in real time. I talk, you can hear me, you can reply, and then I can hear you, and then it's like a two-way communication happening very fast. But ideally, when you send that message, that image, that video, it travels in bits, and then it arrives to that other person and then get reassembled together, and then you now see one image. You now say, oh, I send this person my picture on Instagram, I send this person my picture on WhatsApp, and all that. So yeah, that's what packet system, or that's what packets are, right? So looking at this slide, say you should just imagine sending 10 page letters through the post, right? Instead of one giant envelope, right? You put each page in its own numbered envelope and send them separately. You're sending 10 letters. Instead of putting the 1, 2, 3, 4, 5, 10 letters in one big envelope, you just put, okay, letter A, no, letter 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you now send them. And then they usually take different routes. That's the packet. You can see some will fly, some will trek, some will use a vehicle, some will use private jets, but they will arrive at different time spaces, right? Or sometimes you see them, maybe they may arrive almost at the same time, but they travel through different routes. But the recipients, they assemble them in that order. So now once I send these letters to you, 1, 2, 3, 4, 5, you get them, you read 1, 2, 3, 4, 5. Then you now get the full message. So sometimes these 10 letters may arrive almost the same time. It would be as though I send all of them together, but no, it was sent separately through different routes, right? So basically, that's what packets, that's how you could look at packets, right? They have headers, they have payloads, and then yeah, I'll share this slide. You guys could also take a look at it and then read more details, right? So that's how maybe communication happen on the internet. Routers. I think I also mentioned these guys while I was trying to explain when those packets travel. So remember, they are traveling through different routes. They have to pass through some guys that will redirect them. No, you are going this side, use this road. Come this side, go this road, and you guys can then come and meet here. Okay, this is the junction, take this right and all. That's basically the concept of routers. Those are like postal workers of the internet. Those guys that help you deliver, right? Routers, they read packet addresses, forward them hop by hop towards the destination. So each of those packets has a header. It has a header and a payload, and each of them has like an address. They know where they are all going to, right? So those routers read and then forward them towards the right direction. So just think of a router as a post office sorting room, right? Each packet arrives, the router reads the to address and then send it to the next router, hope by hope, until each arrives at the correct server where those information are supposed to be displayed. So your device now, maybe you are on your device, on your phone, for example, using your home router connected to an ISP router. There's like a backbone. Remember, your ISP guys that are plugged into that main cable, right? That is connected to a big computer, which is like the server, right? So those packets, they take different parts, but they arrive out of order, like I was trying to explain for the case of that image. You could, or even a video, or even conversations, right? Where I was trying to say, okay, maybe you're having like a Google Meet video call, and then you could see the lips move, no words. So it means the video arrived before the actual audio. Or there are times they arrive like the same time. So, but they are auto rerouted, like they are rearranged and packaged so that that communication then flows smoothly, right? Yeah. So this is like the full journey on how you interact with the internet, right? You type your URL, for example, www.google.com in your browser. The DNS guys convert those words to an IP address. The TCP connection, that's your device and the server, do like a 3-step handshake to agree to talk. And then there's a HTTP part that does like the request. This like hypertext transfer protocol. There are different kinds of protocol. So there are different kinds of requests you make to the server. Remember, let's take one step back. When I was trying to explain what the server is, I was like, it's a big machine that allows you to read. Reading information, that's like get. You want to get. It allows you to update. So that's where this concept of cron comes into play when you're building like a backend system. Even as front-end engineers, when you start interacting with APIs. So it allows you to create. Creating now is allows you to store. The R is to read. That's to get those information. And then you can update an already existing information. That's the U now. And then you can even delete a particular information from the server, right? So all those things happen via a HTTP request. And there are different kinds of HTTP requests, right? So if you're going through the learning resource online, on the LMS, you see, or if you're going through the ebook, you see where you have different HTTP requests, like the post request. What the post is doing is like creating. You have like the get is trying to read. You have like the patch or the update. You have like the delete request and all those things, right? And then the server also responds. The server also responds. Sometimes you have like server code. Most times, see like 200. That was like a successful. You see 403 unauthorized. I was trying to have one of my colleagues at the system at the office set up his system. We are getting 403. I was like, I know this error code. It means unauthorized. Just okay, let me check quick. Unauthorized. Or you see errors like maybe you visit a page. Sometimes you see 404. The server will respond with error 404. It means that resource is not found, sort of. So the server also has like its own code language that you also try to bring back, right? So maybe as an engineer, you're expected to maybe even understand some of all those things. I think that is also captured in the ebook and in the LMS resources as well. So your packet route back, we have explained the concept of packets, and then your browser then display those informations to you, right? So it now renders those information you're trying to view. It could be a video, it now brings back your video, you now have a video to watch, and it could be a picture, you can now see the picture. It could be whatever, maybe a call, you can now like be able to make that call, right? So basically this is like the full journey on what happens whenever you type www.facebook.com, www.ig.whatever.com. This is the journey that goes on behind the scene before you get to see that information that is displayed on your device. I don't know if there's a quick reaction, quick questions or quick reaction before we could close. We have just 15 minutes left for this call. Any quick reactions?
Good evening, sir.
Yeah.
Good evening, sir. I've not been seeing
Okay.
anything on your screen since.
Oh, you're not seeing. Don't worry, I'll share the slide, right? So maybe when you go through the slide is gonna make more sense. Okay.
Okay, thank you.
Yeah. So now your ISP is the one not allowing you full access to this resource on the server. Yes, shoot, please, Destiny. Yeah.
Is it only if we are using maybe Chrome? Let me say, for example, now we are using social media. The way you talked about packets, is
Mhm.
it like you are sending a text to someone? Is that how
Mhm.
your text didn't break before it's reached? Then the routers will now rearrange it for it to get to the next person. That's
All
my question.
communication on good question, right? Great one. All communications on the internet happens are being sent as pieces called packets. You asking me that question now, your words were coming as pieces, as packets to me. So when it got to my device, it was able to reassemble in real time. So it happens in milliseconds that you did not know a thing like that even happened when it happened behind the scene. That's why sometimes somebody will even send you a video. You see that, oh, that video has delivered, it's on your device, but playing it now takes some time again for you to maybe download it, reload. That's like assemble it and then you can start watching. Or that's why sometimes you even visit a website with an image and then you see one broken kind of thing. That's why sometimes you even see the image, but the image is blur. That's why sometimes you be streaming and then you see it's cracky because those packets are trying to reassemble together.
Okay,
Yeah.
sir. Thank you so much. Okay, sir. Another question.
Yes.
So now, for example, when you are talking, there's like a
Mhm.
delay. There's like a delay. Sometimes
Yeah.
your image goes blur. So is it because the message you are sending is the packet, or is it the internet that is delaying? So which one causes the delay? Like for example now, if you are talking, there's some time that it sees I will not hear you. So is it
Mm.
also what's causing that delay in between? Whereby I already have access to the internet. That means I'm already connected to you. What is causing that delay in between?
Good question, right? Sometimes two things. There is the server response time, the time it takes for the server to respond, right? So that's why most times, if maybe for backend guys, when they are building APIs, they make sure they want to track the performance of their API to see how many milliseconds does it take if somebody try to log in. Does it take somebody to log in? Let me give another instance. You try to log into a particular system, you see the thing will load, then you're now logged in. It took the server longer time to validate your information and then send back a response that, oh, this person is an authenticated user before the client side. When I say client side, you know what I'm referring to. The front end now redirects that person to the right place. You get? So, one, the time it takes the server to respond. Two, your ISP provider. Oh, sometimes we have MTN has network issues, and then you now start, maybe you can even send the WhatsApp message, it takes time for it to get delivered. Your ISP is the same thing, like bringing it back to the analogy of what I was giving you. Maybe your water is running low in your GP tank in your house. You on the shower. It is not going to run as fast as when you have full tank of water. You get? That's just
Yes, sir.
the two
Sure.
things. Your ISP and then probably the response time from the server. So basically, in all these lessons, in all of today's master session, these are like the key vocabularies, the key words we dealt with. We talk about internet, a global network of computers connected by physical wires. Clients, they are your devices, the things you can see, interact with, connect through an ISP, and then make requests to the server, right? Your IP, a unique number assigned to every device that is on the internet. And then packets are those small chunks of data. And then we say your Wi-Fi is just a wireless connection. Same as your internet. It's just that there's no cable, but it's just like the last meter of it that is being cut off and then made globally available, right? The server is just a computer is directly connected to the internet. It stores and then allows you to access information. We talk about ISP, those are like your service providers, the DNS, your domain name system, that translates those names into the IP address. We talk about routers, we talk about the browser that helps you connect to the internet, right? And yeah, so I'm like I want to convince myself, now that internet is a wire. Whether you like it or not, it's a wire. You can also go ahead and do your own research, right? It is not a cloud. It's just a physical cable that connects the whole world, right? So servers store content. We talk about this. DNS is just a phone book. Data travels as packets. Routers act as post workers, and then packets can take different paths and arrive out of order. And then the TCP now is the one that reassembles them together. So at this point, I don't know if we still have any further reactions, questions. If not,
Okay, a quick
how,
one
how
on this
was this?
internet issue.
Yes, ask.
Okay. Okay. Yeah, on this internet matter, a little one to for clarification there. Now, knowing that this internet is a cable that sits in a particular location that needed to be
Is people just
that,
travel around?
that needed to be tapped before access is
Mhm,
granted.
mhm,
Now let me come like this. Let's say in Nigeria
mhm,
we have our own internet, our own sitting cable
mhm,
somewhere, which
mhm.
can grant us access. How this connection is possible international wise?
Good question, right? So that was what I was trying to explain to you, that international wise, what it means is that cable travels internationally. So basically, like I was trying to explain earlier, in Nigeria, when if you remember when I asked how do we have internet in Nigeria, it's because a cable is buried from a far country, from somewhere passing through the Atlantic Ocean, and then that cable got to Lagos, and then from Lagos, that cable started being distributed out as internet, or as, yeah, started distributing
That's
out,
fine.
giving us access.
That's fine. That's
So
fine.
basically, it's just a cable going from house to house, from house to house, from one country to another, from another country to another.
Like NEPA light
Then
running from foot to foot.
you get like
Yeah.
NEPA light running from pole to pole.
Yes.
Yeah. That's just internet. It's a cable traveling from one country to another, connecting
Okay.
computers, right? And those computers now store information for us to be able to access.
Okay, sir. I have.
Moderator. Okay. Somebody want to talk. Oh yeah.
Okay,
Yeah.
sir. I have like I want to know the cable, which is the internet, connect to the server. Sir, can
Sorry?
you hear me?
Yeah, I
The
can hear you.
cable, which is the internet, is connected to the server. So, like, my question now is, if let me say in a community we decided, I know it's a machine that anybody,
Mm,
we now say a server, then we now connected the cables, then we now have like our own ISP, which is the internet provider. But,
yes.
Sorry,
I
but
think there are
question.
countries currently doing that. Yes. Where you can, like, maybe we could just, Nigeria for example, could then maybe mount servers somewhere, connect those different servers, and then have ISPs, and then only Nigeria will now have that network. Yes, already we have Glo now.
okay, sir.
That's what Glo is doing.
All right. My question now. Mr.
Yeah,
Sam.
guys, we're almost
Uh,
out of time. Yes.
okay. A quick one. When you were discussing this packet, although my this in cut off, but I think I missed some part of it. On the packet, that every information, whether be a media, a voice, or whatever form it is, that each of these things are broken into pieces, and with these
Yes.
pieces having, let me say, an address or a code or a number that they are
Mm-hmm.
identified with. I want to ask this
Mm-hmm.
question in respect that security matter. You know, we are currently faced with a lot of lies in our country.
mm,
Now,
mm,
I will go straight into the question. Like this bandit now, posting video, photos, and probably making calls. I read the news,
mm.
I read the news this evening that the bandits were using a more sophisticated machine that cannot be tracked or whatever. My head wanted to get, but I said let me just leave it. Now with this thing now, how on earth will somebody make a video or post a picture or a voice, make a call, and you say the person is not trackable?
So the thing is, people can only try to hide their addresses. But one thing I want you to understand is every device has a unique IP address that is tied to that device. Like your phone, for example. You can check your phone, it has its own unique IP address. Somebody can locate that phone. Once that phone is connected to the internet, right, using an ISP provider, it becomes like an open space. That's how most times you see maybe those guys in that have good infrastructures are able to track people. And that's where you now see the concept of VPNs coming on board, trying to tweak your IP address. Trying to use a VPN to change your IP address does not mean that they do not know that this particular PC, this is its IP address, just that it's bouncing in different locations. Or it's like this device, my device is in Canada or my device is in US, but I'm seated in Nigeria. But we know that the device you're using, this is its IP address. So tracking any device on the internet space is possible if you're using the right tool. Nigeria is just a funny country. Let's just leave it that way.
It's okay.
All right. So, thank you so much, guys, for making our time. I want to believe this master session was actually resourceful. I'm also going to share with us the breakdown of how our lessons are going to be. This is like the plan. What I plan to do is I want us to do HTML, CSS, and JavaScript under 4 weeks. How are we going to do that? In week one, I expect us to be learning HTML, CSS, and JavaScript all at the same time. And at the end of the day, we build a bio page. How are you going to be learning that? I already structured that. Week one, under HTML, this is what I expect you to cover. Under CSS, this is what I expect you to cover. Under JavaScript, this is what I expect you to cover. Then in um, our weekend workshops, we then now put all these learnings together and then build something out. Could be live coding project, right? We build it, I will explain all the concept and then we build things live out. So with two, this is what I want you to learn for HTML, this is what I want you to cover for CSS, this is what I want you to cover for JavaScript. Weekend, we are going to build this live, right? I'll explain and then we could maybe I explain and then we'll build it, right? So you guys are going to get this document. Yeah. So thank you. Please, if you have not subscribed, please do well to do that. Those that applied for scholarship, I think I've missed a couple of people, and then yeah, some of my friends wanted
Study
to
part.
tune in, but some didn't want to. The reason being that was a very small amount that at least anybody should be able to put that as a commitment. But I was like, some people actually don't have it. So, but yeah, I'm still pushing for it. We'll see what will come out at the end of today, tomorrow. So tomorrow we'll be also having another master session, basically on software development lifecycle. Thank you so much, guys, for your time. Do have a wonderful evening. It's 9 p.m. Bye for now.
Thank you, Mr. Samuel. God bless you.